Hi everybody, this is our video that we're going to do for Chapter 7 practice. Before we get started, I want to tell you a little bit about Chapter 7. Chapter 7 is largely, in my opinion, probably the hardest chapter for the students to grasp over the course of the entire semester. So we're coming off of Exam 1. I don't know if you've talked to as many students as I have, but they're all kind of really sad about Exam 1. So they're in a really vulnerable state right now, and I'm getting ready to throw the hardest content at them as well. So try to be gracious with them. Try to be understanding because they're in a really, really tough situation for them right now. Now, between you and me, it's all going to be fine. It's all going to work itself out, and that's what I keep telling them. Eventually, their light bulb is going to go off and it's going to click. So, likely to you guys, when you look at the exam, you think, this is easy. This is exactly what we did in class. This is just very basic. And it is, except that they've never seen it before. So try to bear that in mind. They haven't ever had a teacher like me. They haven't ever dealt with things like this before where they're smacked in the face with a question without step-by-step instructions. It's new territory for them. And even though we told them it was coming, it's still a shock. So now we'll get started with Chapter 7, which has the nested index match, the and or not logic, the nested if functions, as well as cumulative interest and cumulative principal. So it's a lot. It has database functions in it as well, which database functions are cool. It's kind of a neat little trick that we can do. It basically is a sum if and an average if, just in a different way to get it. So we'll look at database functions. They're not as useful probably in the real world as they are kind of a cool concept. So we will do them, but they're kind of not the meat and potatoes of this chapter, if you will. So let's get started. The first tab that we have in this lab is going to be index and match. And index and match go hand in hand. They are lookup functions that serve different purposes within Excel. So up until now, we've used VLOOKUP and HLOOKUP. For the rest of the semester, while we will go back to VLOOKUP and HLOOKUP, we probably will use index and match much more because they don't have the same restrictions as VLOOKUP and HLOOKUP. The students may or may not remember, but when we do a VLOOKUP, let's say we're looking for this Olive Glow beauty party and we wanted to look up its value from Q1 in this cell here, we would say, let's say we wanted to do a VLOOKUP in this yellow cell to find the Q1 Olive Glow beauty party. We would do equals VLOOKUP, and then our lookup value would be Olive Glow beauty party. Our lookup table array, and here's where the students get messed up, right? They want to come down and they want to select all of this. Really, that's not what we need. We have to start with whatever our lookup value is in the leftmost column. This is where they struggled on the exam, and this is what I want you to walk through in class, how this works if I was going to do a VLOOKUP for this particular thing. My next argument is column index number. Here I have items in Q1 selected, and I want to see Q1, so my column index number here is 2, and my lookup range is going to be false because I want an exact match to my lookup party. And so my VLOOKUP works, and it tells me that Olive Glow Beauty Party is 5425. So that's how the VLOOKUP works, and that's all well and good, and that's what we've done up until now, except now, in a more useful context, we have these drop-down boxes. These data validation lists, if you will, that I've created, and the students know how to create data validation, and we'll learn as we go forward how to make these lists with data validation as well. But this is a data validation list where I can simply select the item that I want to do, and so my VLOOKUP changes. Now I have catering dinner. My VLOOKUP changes. If I go look at catering dinner in Q1, that's the right value. The trick is here. There's another drop-down box that says I can select the quarter, but you'll notice no matter what quarter I select, it doesn't really work because it's not changing, because there's nothing to tell it to change column index number based on what I put in this other drop-down box. So here's where index match comes in. In this cell, we're going to use a nested function. This is our first nested function. All a nested function is putting one function inside of another to serve a particular purpose. So first let's take a look at these two functions over here. I'm going to search index, and show you what the index function says over here. I'm going to just do the first one, right? So index says returns a value or a reference of the cell at the intersection of a particular row and column. So index gives me the intersection of a particular row and a particular column. In this case, it's going to give me the intersection of catering, dinner, and Q1. So if I wanted to do this just an index based on these two values, I could do that. So no matter what I want to do, again, I could use just index for this function. So if I do that, index, and we'll do index array, that's going to be, it's not what I want. Index array is going to be, the first one is going to be the one that we want. So if I would make it stop doing this, okay, index. Array. Our array is going to be down here somewhere in this table. So our array is going to be locked down somewhere in this table. Somewhere in this table, I want you to look for the intersection of this particular row and this particular column. My row number for catering dinner is going to be, let's see, row 1, row 2, row 3, row 4. It's going to be row 4. And my column number is going to be 1, 2, 3, 3. Column number 3 for Q1. And I'll close my parentheses and I will get catering dinner 3,651. That's exactly what I wanted. So I have this index function that says look in this array and look in the whole array, and I include the column headers and all the way to the left hand side. I do that for a variety of reasons that we're going to talk about as we go forward. But in this whole array, I want you to look for catering dinner, which happens to be on row 4, 1, 2, 3, 4, and column 1, 2, 3. So again, I have to know what column and what row these particular things are. Now when I change this, it doesn't do anything to my index match function. So again, not the most useful thing in the world. So here's where our nested function comes in. We're going to do match. And our match function, in case you've never used one before, our match function tells us, returns the relative position of an item in an array that matches the specified value in a specified order. So basically the match is going to look up this gift basket delivery large and tell me what row it's in. So I'm going to use these two things together. So here I'm going to do equals index. And it's going to ask me for the array. And the array is going to be all of the data including the column headers. So all of the data including the column headers, because the column headers are what I'm going to change here. So my entire array. My row number, I'm going to use a match function. So I'm going to nest a match function here inside my index. And my match function, if I go back to index, my index function now wants to know row number. So to find row number, I'm going to use a match. And row number is going to be based off of whatever is in cell H2. So you can see as I go down, the rows have the items in it, which are what is captured in H2. So my match is asking for my lookup value being H2, my lookup array being right here, including the column headers. Again, I have to go all the way to the top of the thing that I selected as my index array. If I don't go all the way to the top, it's going to mess up. It's going to be off by 1. So my lookup array is going to be just the rows, just the places where gift basket delivery large could show up. And then my match type, again, will be false for exact match. That's going to capture my row number. When I push comma, you'll notice Excel knows I'm back in my index function. So I had to use the parentheses to close out my match function. And I push comma and I'm back in index. And now it wants to know, well, what do you want me to do for the column number? Well, the column number is going to be based on this Q4. So we're going to select Q1, Q2, Q3, Q4, and it's going to be based on this. So we're going to use another match function. And we're going to say this time my lookup value is going to be whatever I select in I1. And I'm going to say, where's my lookup array? My lookup array is going to be all the way across. Remember, I selected all of this for my index array, so I have to do the column headers all the way across. So I'm select A3 to F3. And then my match type, again, I want it to be exact. I will take false. I'll close my match by closing my parentheses and realize I'm at the end of my index arguments, so I'll close that up as well. Now, that's a very complicated formula, and you're going to want to go up here and probably copy it and not delete it, hopefully, and paste it over here, or put it in a text box or whatever you want to do just to make it bigger so the students can see it. I copied and pasted it here in this cell. I'll drag it down here so that I can make it super big and it still show up on my screen, right? This is my index match function. The way that I made this show the equal sign in the function is by putting an apostrophe in front of it. It tells Excel that I want this to be text. I don't want it to actually perform the function. So that's real helpful to the students if you can make that bigger. But that's what's happening here. So now I have this index, which is looking for a table that I then want to find a particular row and column intersection. So I use my array, and then it asks me for the row. So I use my match function to capture which row I want based on this drop-down box here. And I use another match function for the column. So this match function is going to look across here and try to find Q4. So I'm going to select Olive Glow Gift Party, just because it's the top row and it's the easiest one to see. So top row, Q4, 1062. If I switch to Q2, it is 9568, Q2, so on and so forth. So now when I do these drop-down boxes, it's much more dynamic. I can calculate much more useful information with this nested index match. The number one thing that students will mess up is when they select all of this data for their index array. So here, A3 to F11, when they select this, when they get inside their match functions, they will forget that they also have to go all the way and include the column headers, so it messes it up. So that's the number one thing they mess up. So that's going to be a super challenging tab for them. This is going to be really hard. There are going to be lots of questions about this. So I'm not saying that you have to do it first. You can do it whenever, but know that there's going to be a lot of challenges here. Additionally, there will be lots of challenges on this tab. So here it says, please show if each sales rep met or did not meet their individual sales goal. Use an if function in column D, an and function in column E, an or function in column F, and a not function in column G. You'll need an if function as well as an or function for column G. So there are many ways to accomplish this. This worksheet is designed to practice and, or, and not. So there's a lot of ways to get this, but we're going to do these and, or, and not functions here. So here in column D, I just want an if function. So did they meet their sales goal or not? So equals if, and there's going to be two outcomes. Either they met them or they didn't. So is Jordan Hinton's sales less than or sales goal? If the sales are less than the sales goal, and I'm going to absolute reference the sales goal, if it's less than, if Jordan Hinton's sales are less than this, if that's true, then he did not meet his goal. If that's false, if they're not less than, we'll say goal met. What they type here is very important because we're going to use what they put in these quotation marks, what their arguments, what the values are to do the rest of them. So Jordan Hinton did not meet his goal. Let's find somebody who did. Chiquita Walsh did meet the goal, so on and so forth. So again, that works because I absolute reference the goal, and we're good to go. That's an easy one. They should be able to wrap their brain around this one. So the gold producers, they met sales goal and client goal met. So they have to have both. So this one equals and. So and gives us a string of logical arguments. So in this particular case, I'll have logical argument 1, logical argument 2, but and tells me that both of those things have to be true in order for this to return true. So here, my logical 1 is their sales goal. So sales goal greater than or equal to 500,000, and we'll lock down 500,000 because we're going to drag it down. So the sales is at or greater than the sales goal. That's logical test 1. Logical test 2 is the new clients are greater than or equal to the new client goal. So hopefully that makes sense to you. The and logic. So their sales need to be higher than or equal to the sales goal. Their clients need to be higher than or equal to the new client goal. In order for them to be a gold producer, they must have met both of those. So when you hit enter, it says false unless they achieved both of these goals. So you see Jordan Hinton, his sales goal is not met, so he's going to be false automatically. Chiquita Walsh met the sales goal but did not meet the new client goal. We'll go down here to one that says true. Nehru Bowers, 30 new clients, 954,000 in sales, met both. It's true, so it works. And, or, and not are going to produce either true or false options. So that's just their output. They're Boolean fields, and they return true or false, meaning that both of these are true or both of them are not true. So there we go. So the silver goal says sales goals met or new client goal met. So here we have or logic, which means I'm going to have these same two logical tests, but when I type or, it means only one of these need be true. I can have 100 logical statements here. Only one of them need be true for me to get a true statement here. So now we have sales greater than or equal to the sales goal and new clients greater than or equal to the new client goal. Same arguments, just different logic this time. Now it's or. Both of them, or one of them, not both, one of them must be true in order for me to get a true. So here they met the new client goal, so I get a true. Here they met the sales goal, so I get a true. Again, down here, where Nehru Bowers met both, or gives me false because it's not both. So we don't want Nehru Bowers to be a gold producer and a silver producer, so this gives me, hold on. Oh, I didn't absolute reference them. That's the problem. I was like, that's not how that's supposed to work. Hold on. So if you don't absolute reference your goals, they will move down on you, and it will do exactly what it just did. There we go. So if they have a true over here, they should also have a true here, which makes a lot more sense because or tells us at least one of them must be met and tells us that both were. So they're going to be gold and silver producers, which logically makes much more sense in my brain. So rookie, we're looking for a not. So no goals are met. So here equals not. And then inside this not, we're going to need an or. So inside this not is going to return, it's a logical, let's go back to not. Not, we have one logical argument. And this means, is this false? And so if it is false, it's going to return true. Not is a very tricky one. Not is not going to show up on the exam. It's a very tricky function because it is counterintuitive, but we are going to show it in this one lab. So we're going to use our or logic again, and we're going to say new clients greater than or equal to 10, lock it down, and we will do the same. So sales greater than or equal to the sales goal, and absolute reference that so that I don't make the same mistake. And I have greater than or plus, which is not what I want. How about equal to? Because that's going to go crazy. There's my or. So if one of these is true, it's going to return the value true. And the not is going to flip the value of true to false. So I only want this to say true, that they are a rookie producer if they don't meet either one of those goals, and that's what the not will do. So it's going to basically do the opposite of the or, which is what we want in this particular case. Not. What did I do? Oh, I've made a mess. Hold on. I want C15. I'm not sure what I did here. Okay, so I'm going to delete this piece. And I'm going to say new clients greater than or equal to this function F4. Here we go. Now we're in business. Okay, so you have to be really careful because I was clicking on things and making it go all wonky, and then I started to type my plus signs into equal signs and it made a mess. But this is the actual right one. So if both of these are false, the rookie producer should in fact be true. If one of them is true, it should read false, and you'll notice it doesn't. Again, it's just the OR logic. Is one of these true? If one of them is true, it will read true, but I don't want it to read true. I want then it to read false. So it's a very backwards logic, but it just reverses it and allows us to do this. Again, we could do it with if statements. We could do it with a lot of things. So there we're just practicing and, or, and not. This nested if is another one that's super fun. So in this case, we are going to want to put today's date in this cell. And let's see. Please calculate the bonus to be paid based on years of service. Please give employees with more than 10 years a $5,000 bonus, 5 to 10 years a $3,000 bonus, less than 5 years a $1,000 bonus. So first they have to calculate years of service. We've learned a couple ways to do this. The easiest way is today's date, well, in parentheses, today's date minus their hire date, close parentheses, divided by 365 will give us 17.2 years. That's how they should have done it on the exam. There's other ways that they can do it now. Now they have seen year frac, which is a cool function. They can do year frac, and we can do start date, which would be hire date, and we can do end date, which would be today. Close our parentheses, gives us 17.2. Here I will show year frac, and I will leave it. And you'll notice when I copy it all the way down, I forgot to absolute reference again. This is what happens when Professor King teaches with a headache. But here we go. So I will absolute reference B2, function F4. And then perhaps it will stop giving me all these wonky answers. So now we come to the nested if statement. They're going to struggle still with this years of service. It was on their exam. A lot of them had a lot of trouble with it. So make sure that you show them how to do it again. Don't just say you know how to do it. Please show them the way that we learned before, and then show them year frac, which is also just as handy. So now this nested if. We have three options. Either employees get a $5,000 bonus, a $3,000 bonus, or a $1,000 bonus. There are three outcomes, which means we have to have two if statements. So here we will start with one if statement. And our if statement is very important to them at this point that you say you have to think like a computer. So here, computers read from left to right, and they forget things. Like once one of these arguments in here is true, one of these logical tests is true, it's going to fall out of this if statement. So I want to figure out the best way to logically make it fall out. So there's a lot of different ways that you can do it. You're either going to start at the top and go down as you go, or you're going to start at the bottom and go up as you go. I recommend starting at the top and going down. It's the way my brain works. So here, I'm going to start with the employees that have been here for 10 years. So if their years of service is greater than or equal to 10, what do I want the value if true to be? If they've been here for 10 or more years, they get a $5,000 bonus. The value if false, here's the other if. So if they haven't been here 10 years, there are still two options left. So here's the other if. If they've been here greater than or equal to 5 years, so we already tested were they here for longer than 10. Now we're going to test are they here longer than 5, because this range from 5 to 10, I really only have to test the lower limit because I've already tested the upper limit. So here, if their years of service is greater than 5, I want them to get a $3,000 bonus. If it's not greater than 5, I want them to get a $1,000 bonus. Then I'll close the parentheses. That's my whole value if false for my original if statement, so I'll close that set of parentheses as well. You'll notice Lisa Page has been here 17 years. She gets $5,000. Hector Taylor has been here 5.1 years. He gets $3,000. Brian Duran has been here 3.6 years. He gets $1,000. This works on all levels. So that is the correct answer. Should give you a total of $2,593,000 for your bonuses to be paid. So hopefully that makes sense. I think that's the